Okay, I think we're just about ready to get started. I see people are streaming in, so that's great. So hello and good morning everyone, or good afternoon, good evening. I see people are joining in from all over the world. I see Europe, I see South America, I see the US, so that's great. Welcome to our second installment to the State of .NET Online series of events. Very happy that we are able to do that. It's still a little bit of a makeshift setup as we are still stuck at home here. But the last one went pretty well, so I'm very optimistic that this one will go pretty well too. So let's dive right in because we have a ton of stuff to talk about today. Let me advance my slide deck here. Before I start, let me introduce myself. I see a lot of familiar names in the stream, but I also see a lot of people I don't know as we have a fairly large crowd. So my name is Markus Egger. I'm the President and Chief Software Architect of a company called EPS Software Corporation. You probably know us better as Code Consulting, Code Magazine, Code Training, Code Staffing, and a few of those. So that is what I started and founded now well over 25 years ago. I spend a lot of my time doing presentations, now a lot of them online, in the past and hopefully in the future, a lot in live events of various sizes ranging from user groups to all the way up the big Microsoft conferences. I am a Microsoft Regional Director, and I want to point out what that means exactly. So being a regional director means I have an official relationship with Microsoft. I like a lot of Microsoft stuff, but, and I want to make that very, very clear, I am not a Microsoft employee. So I can do and say whatever I want. I just have access to a lot of inside information, but I'm not getting paid by Microsoft or anything like that, and I don't have to follow their party line, so to speak, and I can tell you whatever I want. So that's kind of a secondary thing I do, but the main thing I do is probably like most of you guys on the call. I do a lot of presentations, I do a lot of development, probably 80 to 90% of my time goes into doing production development. And that's part of what I want to share with you today is my experience that comes from all that. Also, I want to tell you a little bit about my company. This is not going to be a marketing event, but my marketing people always tell me I have to have at least one marketing slide in there. Here it is. This is what we do. We help people build better software. We do so on the Microsoft platform, we do so on the Apple platform, on Amazon, on Google, and so on. So we have a little bit of a Microsoft background, but we do the whole range of things. And that includes anything from mentoring for an hour to writing custom apps for a year with 10, 15 people on a project to helping internal development departments out with certain specific needs or problem solving and so on. So the whole range of things, we do web apps, we do Windows apps, we do mobile apps, cloud obviously, database development and so on and so forth. So that's it about code and what we do. That's the marketing slide. I also always know that people that come to these events, they often have extra questions. Now you're free to ask questions here. I have somebody who's monitoring the live feed and passes those questions on to me. So I'll try to respond to as many questions as I can during this presentation here today. But at the same time, if you have a bigger question, it's usually not enough to just do a Q&A here. So what we do is we advance an offer to everyone who came to this and say, if you have any questions, feel free to contact us. We're offering you a free hour of consulting or thereabouts. If it's a little more, that's fine too. And in general, I always tell people, consider us a resource. We do a lot of community stuff. We do a lot of passing on of information. And we're not the kind of company who's going to send you an invoice for a quick answer on your technical problem. So keep that in mind. Now, with that said, we'll move on. We do ask people, if you like this, follow us on social media. tell people about this event. We've had relative rapid growth since we've moved this online. So people are excited about these events. It's free content, so what's not to love, right? And therefore, feel free to pass this on to your friends, to your colleagues. I think it's just kind of a cool offering that we have. Okay. Now, for those of you who are new, what's the State of .NET Online thing all about? Well, normally, State of .NET is a series of live events. We go to different cities. We usually partner with Microsoft or somebody like that, use their conferencing facilities and do a live event with however many people show up at that location. Now, obviously, due to the current crisis, we couldn't do those types of events, so we decided to move it online. And so far, that's been received great, and we'll continue doing that. So we will continue at least a monthly schedule with these events. We have lots and lots of topics planned. Next month will be Blazor. We'll talk about cognitive services, other clouds as well, DevOps, and so on. And please feel free to send us suggestions as to topics you would like to see. So that's going to go on for the foreseeable future. We're going to continue doing these State of .NET events online. But as soon as it's possible, we are also planning to return back to doing live events because we think that's important as well. So in the future, hopefully we'll have a combination of two different types of State of .NET events. So let's dive right in and let's talk about the topic at hand. Here is what we have on the agenda for today. Today is going to focus all on Microsoft Azure. That's a huge topic. It's kind of cool that we have these dedicated monthly topics now where we can focus on a specific area. That'll allow me to focus a little bit more on what's going on in Microsoft's Azure Cloud, especially from a developer's point of view. Now, Azure is huge. So even with a dedicated event for Azure, there's only so much I can cover. I can barely scratch the surface on that. But still, lots of stuff that we'll be able to look at. We can dive into some detailed examples. A lot of people, especially from Microsoft, do this format where they do the 5 most important things around Azure. I'm kind of following that a little bit, except we'll have more than 5. So we'll dive into some of them in detail. Some of them I'll just point out to you. But with that said, there's so much to Azure, even beyond development. We can't even really truly talk about that part, but even just the development part about Azure that interests us as software developers. There's hundreds of services and we can talk about all of them, but I'll try to give you a good overview and I'll try to show you some real world examples of things we have done with Azure that I can show you. A lot of the things we do as a company is for other customers that are under NDA and we can show them, but I have a number of examples that I think are interesting, that are very concrete and that I can show you. We'll also start out showing some of the basics. I understand that a lot of people know more about Azure at this point and don't need to go back to the basics, but there also is a new push of adoption due to this crisis now of people that have never dealt with a cloud environment before. And so we'll start at the basics. If you already know that, hang with me. We'll move through that relatively quickly and then you'll see the more in-depth, detailed, latest stuff from build and so on. So let's get going with an Azure overview. What is this thing exactly that we are talking about here anyway? Well, first of all, Azure is obviously Microsoft's cloud. And when we talk about a cloud, that's in a lot of ways really just a fancy term for very, very big data centers that exist somewhere else. And you just reach out to it over the internet. The name came from usually having a cloud symbol on PowerPoint presentations and so on. So I think that's probably the part that most people know anyway. I think what most people don't necessarily understand is just how big this thing really is. And so I'll show you some examples of how big some of these data centers are that Microsoft runs at this point, how rapidly new ones are coming online. Now, I also want to point out, we are focusing on Microsoft here today, but Microsoft is not the only cloud provider out there. It's, to me, a very appealing one. The Microsoft Cloud effort has been hugely successful. They are clearly among the leaders, if not the leader. At the same time, there's other cloud providers that are very, very interesting. Amazon, of course, hugely successful as well. Very, very interesting cloud offering there too that we use in addition to Azure. And that may be the topic of a future State.net because it's very interesting for developers, even with a Microsoft background, to talk about AWS and the Amazon offerings. So Azure is by no means the only game in town. There's also Google that's very interesting. There's some Asian cloud providers that are very interesting. So lots and lots of stuff to use there. And the interesting thing is most of the time, you don't have to focus in and select one cloud provider. We are using a mixture of cloud providers. So we may be using Microsoft for AI and cognitive services, and maybe we use them for databases or simple web app hosting. But we may also use the Google Cloud for mapping services. We may use the Amazon Cloud for hosting websites and running databases and doing interesting things there. So want to make that clear from the get-go that this is a little bit more of a well-rounded thing where you can mix and match stuff. But today we're focusing on the Microsoft Cloud, and they have an enormous effort going on, probably the biggest there is. To give you a little bit of an idea, I have some photos here of what a Microsoft data center is like. This is the Quincy data center, and you see this is warehouses full of servers. There is thousands and thousands of servers in there. These warehouses are usually in out-of-the-way areas where land is cheap because it takes a lot of land. They want to have cheap access to electricity. They want to have cheap access to water and cooling, and of course, internet connectivity. And then it's just these huge facilities full of servers, and they are highly secure. I can't mention any names, but I talked to somebody who's very high up in the Azure community, and he was telling me about all the different security measures they have in place. And it's incredible what they're doing. I mean, they have, for instance, rules that you cannot walk into these facilities if you have any kind of metal on your body. So belt buckles or stuff like that just doesn't work because there's these metal detectors you walk through. And there's nothing that goes in and out of these data centers. So you're not taking a server out and fixing it if it's broken, for instance, or a hard drive, because nobody wants data to disappear out of these data centers. So nothing goes in and out. When a server rack is broken to where the servers burn out or something like that, then instead of trying to fix it, they shred it. They have metal shredders the size that could shred a car, and they throw entire server racks in there when they need replacing, just to make sure nothing gets out of these data centers. So that's just one anecdote that's kind of funny, interesting in a way. But I think it also gives you an idea of the scale of the things we're talking about. So that's one of the data centers. Here is another data center in Cheyenne. Same sort of deal. These data centers exist around the world. Here's an aerial photograph of the one in Dublin. And I could go on and on. I have one more here from Amsterdam. So in Amsterdam, you pretty much know when it's a warehouse this big, they're either growing tulips or it's a data center. So long story short, these efforts are humongous, and a lot of cloud providers, or several of the cloud providers, have efforts at that scale. AWS, Google, Alibaba in particular, but Microsoft is the leader there. And another interesting anecdote, Scott Guthrie, who's in charge of all this Azure stuff at Microsoft, was telling me one day, or a small group of us regional directors over dinner one day, that he would have never thought when he was in college that he would one day worry about how quickly concrete could dry, because they're building these data centers literally so quickly that they're worrying about how quickly can the concrete dry so they can move in more servers, and the capacity goes up drastically. So that gives you an idea of the scale we're talking about here. Just at this past build, which happened last week, Microsoft announced several new regions for Azure, which now means we have 61 worldwide Azure regions. And you can kind of see them on the map here with the new ones being highlighted. What is an Azure region? An Azure region is a set of data centers. So that's interesting to understand. This doesn't mean there is 61 data centers. It means there's 61 regions which each have more than one data center for redundancy and for capacity and so on. And there's literally hundreds of these data centers that I now showed you some photos of. And you start to get a feel for the scale of the operation that we are talking about here. And these regions, they exist for availability in various places. They exist because of data regulations. For instance, you see in Europe, there's a lot of different regions. That is because in Europe and in many other places, there's rules that data cannot be taken out of certain areas or has to be processed in certain areas. So Microsoft has more data centers than AWS and Google combined, or more regions than both of them combined around the world. Some of them are government operated to be approved for specific government workloads. In Germany, excuse me, there's a data center that is operated by, it was built by Microsoft, but it's now operated by the German government or German Telecom, and Microsoft provided the tech, built it up, but they're not currently having access to it. And so it conforms with various rules and regulations like that. So interesting to know. Again, it's a huge operation. I have one more slide here just to give you an idea of the size of stuff that Microsoft is trying to do here. This shows the fiber backbone around this. The fiber backbone is essentially cables that are laid around the world. You can see that these kind of follow the outline of Africa and across the Atlantic and across the Pacific. And this is a little bit outdated. This is, I think, a year and a half old or so. So some of these future capacity ones have now come online. And so what Microsoft is doing, they're both leasing some of these lines, but they're also very active in creating this infrastructure themselves. So Microsoft actually lays undersea cables across the Pacific, for instance, to make sure that the capacity is there. Now, there's a question online, how quickly can you replicate between regions? Now, that depends a little bit on exactly what you're doing. It's more of a logical issue almost than an infrastructure issue. For instance, if you replicate data from the East Coast to the West Coast in the US, the Microsoft infrastructure is essentially, as a rule of thumb, about as fast as your fastest local area network would be. So they replicate from Seattle to the East Coast as fast as you would from one office to another in the old brick and mortar office with a super fast local area network. And it's truly amazing when you see some of these performance numbers. Mark Rusinovich did a very interesting session at Build last year where he showed some of the actual benchmarks. I don't have time to go into that here today, but if you ever have the opportunity to check that out, that is very, very interesting. And the performance they get out of this is amazing. Now, of course, if you have a very large database and you replicate from the US to China, then A, the performance numbers may be a little different, and B, even with a very fast network, it may take a little bit to do that. So, but if you have continuous replication, you get very, very good performance out of this. And it is a very common scenario to replicate to multiple locations worldwide, because then people locally have a little bit quicker access if you need that kind of performance. So very well covered there. So long story short with all this stuff that I'm telling you here is I just want to communicate the just unbelievable scale that Microsoft has created with these environments. And again, it's not just Microsoft that does this. AWS is also very, very impressive in how they do that. So Amazon is right there as well. And then a little more distant than some of the other cloud providers, but they are still also at a very, very large scale. And that's very interesting too. Now, just some quick numbers, updated information that has been made available recently. At this point, we are at 95% plus of all the Fortune 500 companies using Azure. Now, again, that doesn't mean that they're using just Azure. It probably means they're using a combination of clouds. But the point being, this has become very, very ubiquitous. So a lot of people are using this stuff. It's certainly not like you're an early adopter if you do this. In fact, at this point, I would say Azure has become very, very stable. just last week at Build, there were a lot of interesting announcements around Azure and some interesting new stuff. But for the most part, it's now kind of settled in a little bit, and it's a stable environment. The old services are not replaced at a pace as quickly anymore. The services are becoming more mature, and it's a very stable platform. Has been for a while now that you can operate on. Also, Azure has an enormous number of certifications. That's very, very interesting, because it means you don't have to worry about those certifications anymore. For instance, we were working with a customer who did stuff in healthcare. Do we really want it to be our business to be certified in all the standards around the world for different healthcare operations? Or do we want to offload it to Microsoft and say, hey, if we use your stuff, we are certified, and make sure that we are following all the rules that need to be followed for a specific area? And so I'm not going to go through all of these here, obviously, but very, very interesting to know that that's one of the benefits you get from running on the Azure cloud, is that you automatically get the benefit of having different certifications and can run in different environments. Now, what's very interesting is in times like these, we used to call this a second push of adoption. Actually, we used to call it a second wave. I don't think we'll be using that term anymore, so we'll call it a second push of adoption. But it's really gone into a third push. So what we've seen over time is when Azure first came out 10 years ago, we saw people that jumped on that immediately, saw the potential, and wanted to take advantage of it immediately. And then that kind of died off a little bit. And then after a while, more and more people that were holdouts initially said, oh, well, look, this is actually working out. This is here to stay. It's actually secure, and we don't have to be afraid of it, and it's not just going to go down, and so on. And then we saw a second push of adoption. And now with the coronavirus crisis, we are definitely seeing a third push for all that. So we're seeing that people are kind of forced to move to Azure now, because all of a sudden people are working from home, and that'll ebb off a little bit again, but we definitely expect to see that that's an area where people can optimize the way they work, where they can do away with the overhead hours that people spend driving to and from work and being stuck there at lunch and stuff like that, and instead allow people to more productively work from home. And Azure is a big part of that, as are other clouds, of course. So we are seeing that more and more people are pushed into this rapid adoption of the cloud. And one of the things that's really interesting about Azure, and I have a slide coming up here in a moment, is that it supports a hybrid approach better than any other cloud. So if you still have your own data center, but you want to move some of this stuff onto the Azure cloud or any cloud, Azure is probably one of your better bets. So some of you may be in the presentation today because of this very reason. Now, another thing that some people may not realize is that Azure is really a cloud for any language and any operating system. So it's not like this is a Windows Visual Studio .NET operation, although those things, of course, run very well on the Azure cloud. But you can run Linux workloads on Azure, and that is very, very common. You can use any language, any development stack to develop for Azure. Very often you will mix and match your things. So the systems we build, some of it may run on Windows, some of it may run on virtual machines, some of it may run on Windows Server, some of it may run on managed services based on Windows Technologies, and then some other part of the app is running on a Linux workload or in a Linux container, or we are using a service that uses Python to do some AI, or we're using a database that's completely not on the Microsoft stack. And Microsoft is happy to help you with all of those. So it's really a cloud for any workload, any language, any operating system, and you can mix and match to your heart's content. So very, very appealing setup there. Another thing that a lot of people don't realize, if you're already an MSDN subscriber or one of the permutations thereof, such as a VSS subscription, it comes with free Azure credit. And you're just losing that if you're not using it. And so usually it's $150 a month. You can use that. You can run your production things on that. It's just a benefit you get, and it actually gets you quite far. So I encourage you to activate that. Now I want to point out a few related things. One is Azure Stack. Again, this is one of the things that Microsoft is really pushing, a unique offering, and that is this ability to combine what they do in the cloud with the ability to use the same technologies but outside of their data centers. And you can mix and match that. So, it may not be very timely to have a photo of a cruise ship on my slide deck here, but it's still, I kept it on there because it's a very good example. So Carnival Cruise Lines, for instance, uses that. They have Azure Stack technology on board of the ships. Now on the ships, connectivity is usually very bad. Anyone who's ever been on a cruise and tried to check their email knows what I'm talking about. So what they do is they have Azure technology on the ship and are still able to run the same stuff. And what it means in their case is they have literally hardware appliances that you can buy and you can put in your data center, and it runs Azure technology for you. So another interesting thing to know for those fringe scenarios. And in general, this cloud versus the edge of the cloud, you're in between cloud and on-premise data, at least for part of what you're doing, is a very, very big topic. And this even goes into IoT devices. And so you can do very, very advanced cloud things. Like you can do AI and you can run AI models and train them on Microsoft supercomputer that they now have even. So very, very large AI capabilities that take huge amounts of computing power. And then once those models are trained, at that point, they don't need as much power anymore, and you can take it to the edge and you deploy it perhaps into an IoT device, very low powered, and that just runs on its own. It communicates with the cloud sometimes, maybe. So it's kind of an edge case, if you will. And that's very, very interesting what Microsoft is doing there with that type of technology as well, and is a clear leader in that. Now, with Azure, there's also two different concepts that not every cloud provider offers. And that is the differentiation between hosting and services. So for instance, one example of hosting would be you run code or you write code and you then deploy it to Azure, such as an ASP.NET MVC application. And that would be just a hosting scenario. In that sense, you can think of Azure as just a huge hosting environment that you can use either because you're spinning up servers there, or maybe even on a higher level where you just say, I want to host this, I don't care what the servers are, and then it just runs and operates. A second level, and a completely different level, if you will, is that of using Azure services. That is a level higher where you actually use things that are only available on Azure or in the Azure Stack. That would be things such as blob storage, which we'll see an example that allows you to store large files. That would be things like cognitive services where you run certain artificial intelligence or machine learning workloads that you couldn't just do locally. And then you're really not talking about, oh, I'm low level generating or creating an app from scratch, but this is a service you use from your app. So you develop on top of a higher level service, which is very, very interesting. And Azure is very good at that. So with that, we are coming kind of to the end of the intro part of this. We're going to dive into it a bit more. So the first thing that I actually want to take a look at, and let me open my browser here, is the Azure portal. For those of you who have never seen this, let me just dive into my portal here real quick, and we're actually going to see some of the production stuff we are doing. So I can go to portal.azure.com. If you already have an account, then that works. You just sign in. If you don't have an account, you can sign up for a free account. And yes, I want to stay signed in. And you can get started for free with some stuff. You can then also activate your MSDM benefits to even use some of the 4Pay stuff. But you'd be surprised how many things you can actually do for free on Azure. So here is the Azure portal as it starts up. Let me go into my correct subscription here. You can have multiple subscriptions. For instance, I help maintain and manage the subscriptions of some of our customers. We're not going to look at those, obviously. That's why I have to sign in into our own internal one here. And so once I have, I'm not going to do that right now. Once I dive in, I, even as my organization, can have multiple directories, multiple subscriptions to Azure up and running. Like this one that we're looking at here is just test stuff I'm doing. We could switch to another one that would be more like our internal EPS one. And as you can see, I have a ton of them. So I think it's this one. But whatever the case might be, the interesting part here is that on Azure, and I find that very appealing, you have one portal through which you can access all your things. In other clouds, that's a little different. You log into different URLs and each service is a little bit separate. But on Azure, you have one large portal that has all the different services that you can get to in one place. Now, there's different opinions as to how much people like the different features of the portal. Personally, I happen to like it quite a bit. And I really enjoy that it's all in one place and consistent. Now, some of the services have secondary ways of getting to it. We'll see some AI stuff in a bit that has secondary UIs, but it's also accessible right here through the portal. There's a question online, am I going to talk about containers and Kubernetes and stuff like that? Yes, I will talk about that a little bit later in this presentation as well. So anyway, this is your portal, and in here you can access all the different things you have. Like here are some examples of things that I usually deal with when I do presentations. So there's cognitive services things in here. These are AI workloads that I'm running. There is app services in here, which are basically things like running a website, like an ASP.NET website or a JSON, a Node.js website or anything like that. There's databases I have in here. They're all accessible right from this one place. And I could drill into some of these. Let's drill into this one as an example here. For instance, I could then see all the things that I need to manage around these services right here in this one portal. And so it's taking a moment to come up. It's loading different things. This would be essentially like maintaining a website. It's a relatively simple service, and I could look through the different aspects of maintaining a website, anything from the typical settings you would have in IIS to more advanced things like scaling out to how much is this going to cost me as I use it. You can see statistics and so on and so on. I can also create new resources right from here, and we'll take a look at that in just a moment. So that is one of the main things I want you to remember. If you've never done anything with Azure, go to portal.azure.com, start signing up for stuff, start trying things out. Things may cost money, but it's for playing around with it relatively easy to see. And if you don't put down a plan that would charge you more, you may run out of your free credits and then your trial stuff stops working. But you shouldn't by accident, unless you go into a higher tier, you shouldn't get charged. Now, you do need to be careful with going into a higher tier a little bit. Okay, now let's go into some concrete examples here. So what I want to do is I want to show you a few specific things that I think every developer should be at least aware of. Some of those things we can go in and we'll dive into in greater detail than others. Some of them I will just point out to you that they exist. But these are some very interesting things. Now, I want to make it very clear that this isn't even the tip of the iceberg. A lot of people always ask me, well, tell me all the things I can do with Azure. That would be like saying, tell me all the things I can do on a Windows machine. There's no way I could tell you all the different apps that are available, because not just Microsoft, but also third-party providers are building more and more stuff that becomes available through the Azure portal to you as a developer or also as a user. Half the stuff on Azure is really geared towards users and enterprises as ready-made software that's ready to use. But as far as we developers are concerned, even for developer offerings, there's third-party providers like database providers, like providers of specific services. Like we use a service to send out emails and notifications that's not from Microsoft, but you can get through it through the same Azure portal. So tons and tons of stuff, no way to even be able to know what's there. There's no expert in the world who knows all the things that are available on Azure. So I'm just going to show you some of the fundamentals and some of the things that I think are very interesting for everyone. But this is in no means the whole enchilada, so to say. So diving in, the first thing that we all need to start with is an app service. When I say app service, think I want to run a website. I want to run a site such as an ASP.NET site or a Python or Node.js site. Think I want to run an API type of setup, web services, REST-based services to get to my data that way. All those things you run as app services, or at least that's one way, the most fundamental way to go. And this is actually a service that we use quite a bit. Now you can go into containerization, you can build large clusters that scale up and down and out automatically, that replicate themselves around the world into the largest conceivable scenarios. But truth be told, a lot of the stuff we do just runs as a simple app service because that's just enough, and it's very cost efficient to do that. So let's go back into the portal and let's take a quick look at how that even works. So let's go close this down here and let's click create a new resource. Now this brings up a unified interface that allows me to create just about any Azure resource. And you see different things in here. You see the most popular ones, and you see that a web app is actually part of this, so we'll use that here in a moment. But we could go and we could search for other things. We could look by categories, or if we have some blockchain related needs, there's different things here. And so you see there's a list of blockchain stuff. That's just the featured one. We can go and to see all, and we'll bring up a list of everything that's related to, in this case, I just happen to be picking blockchain. And so you'll see in a moment that'll come up, and it's going to be quite an extensive list of just this special thing, blockchain related stuff. And again, this is not the whole thing. This is just the most popular ones again, and I could drill into each subcategory and so on and so forth. And so this is just the subcategory of large things. These may be third-party offerings. This is sometimes Microsoft offerings, or often Microsoft offerings. And we could now drill through that one after the other, and you'd discover that there's literally hundreds and hundreds of things related to just that. What we're going to do is we're going to start over here, and we'll create a web app. And when we create a web app, we can then set different parameters that we want to create there. First of all, we have to specify a name for this web app. And of course, it has to go with a specific subscription. And I'm just going to go pick a resource group. A resource group is a way of grouping things together so you can then look at just all the things related to this app or this initiative or whatever. Then we pick a name. Just going to call it State of .NET. It checks whether this already exists. It doesn't, therefore we get a green check mark. This web app is therefore now going to be available as State of .NET .Azure Websites.net. That's its default name. Of course, we can then assign a specific domain name and so on. But that's the default setup. We can also select the runtime stack that we want. So for instance, right now I'm going to pick a .NET Core 3.1 application, but you can see there's the older .NET versions, and there's completely different things like Java, and you can go into Node and PHP and Python and so on. So those are the default things that are supported as an app service. Now, if you don't find what you want, you can always use other Azure services. You could spin up a virtual machine and install whatever you want on it. It could be a Linux or a Windows virtual machine. So you can literally do anything you can do on a physical computer, you can do here as well. So we do that. We chose .NET Core 3.1. We can then choose whether we want a Linux or a Windows install. We can also choose where we want to deploy this to. A lot of our stuff runs South Central US. I'm going to stick that in there as well. I can then pick a service plan, which is the initial setup of my web app. In other words, how big is this thing? How much RAM, how much memory do I have? How many CPUs do I have available? How many servers do I have available for this? And we will go with the basic, which will give me relatively little memory here, but that's going to be fine for what we're doing. And this will be completely free until I start scaling it up higher. I can enable monitoring. This will give me some stats and so on. We don't need that for now, so we'll just move on. Can attach additional information to this. We don't need that. And it gives me kind of a review of all this, and this all looks good, and I just say go ahead and create this. So what's happening now is in the background, Azure is now spinning up a complete environment. This is like buying a server or installing a new virtual machine on one of your servers, and it spins up everything, including the latest .NET Core runtime and environment that that is needed to run all this. And so now this is complete. It happened, almost in the blink of an eye. We can go to this new resource we created, and we could now start setting various additional parameters on this web application. We could set up HTTPS. We could set up a custom domain. We could change the size of this. We could see different stats, as you can see popping up here. Of course, they're all empty at this point because we just created this, but this is now starting to collect some data about our application. Also here, it shows the default external URL. Again, you can change that to whatever domain you want. Ultimately, we wouldn't use Azure Websites.net most likely. But we could now go and browse to the site, and this is public, so you could now do this as well. You can go to this website, it now exists, and it has a default placeholder site up and running. Now we could turn that off, and we could manage this any way we wanted, but that's the default that's there. Now at this point, we could go into our Visual Studio, and we could start building a web application here. And I'm just going to do something very, very simple. In fact, I created this yesterday. The cleverly named Web Application 3. And this is just a standard ASP.NET web app. It's a whole interesting topic. How do you build web apps that really take advantage of the Azure functionality? But for now, this is just a super simple web app. It's basically the default ASP.NET template. The only thing I think I changed is that I said, hey, welcome to State.NET rather than just ASP.NET. But very, very simple, very straightforward. Now we could now deploy this web app to our new cloud-based infrastructure. The easiest way to do this is to use this Get Publish Profile button here. We can click that. It downloads a publish profile that tells us how to deploy. And we could go back into Visual Studio here. We could right-click and choose Publish. Thinking a little bit. Visual Studio is a little bit slow in my case because I'm running so many things to do this broadcast. Okay, it's still loading, it says. Still thinking. There we go. Ooh, this is slow. The corner still says processing files. Be there in a moment. If you have any questions right now, be the perfect time while this loads. There we go. So here's my publish interface. I already tried this out yesterday in my preparation. So but what we'll do is we'll pick a new publish profile here. It says, where do you want to publish to? And I could now go in and I could set up a lot of these things manually, put in a lot of parameters, publish to various things from here, of course. But in our case, we just say, now we want to import a profile. And we're going to browse to that. Oops. No, we do not want to configure the dependency. Okay, here's our publish settings. We'll just import that, and that'll have everything we need to publish this application to Azure. Now, is this what you will typically do? Probably not during production. You could do this on small websites, but most likely during production you will have things like Azure DevOps or GitHub DevOps or some other DevOps solution where you can do continuous integration and you get automatic rollout to different app services and so on. All of that is supported in Azure, but we'll do the simple thing right now and just deploy this web app manually. And you'll see that once this deployment, hopefully it won't take forever, once this deployment is done, normally this goes, when you try this at home, goes in a matter of seconds. Just my setup with all the streaming is a little sophisticated here. But it's a pretty straightforward process. There's a few questions online. Can you do Windows machines or things like Parallels on Mac? You can absolutely do Windows virtual machines in Azure. So you can do virtual machines because you want to set up a virtual server, or you could do virtual machines just because you want a VM that you remote into. So if you just want to try out Visual Studio vNext real quick, there's probably a virtual machine that you can spin up that's already configured for you with the latest bits installed, and you can spin that up and you remote into it, and there's your virtual machine. Or maybe you need a machine with Visual Studio 2017 and you don't have that around anymore and you just need one quickly, and so you could spin that up too. And there's Linux boxes and so on. I believe, I haven't checked on that lately, but I believe Apple still doesn't allow us to do a Mac type of thing. So that is something that I think you cannot do because of the Apple rules, but I haven't checked on that lately. Another question online is, what is gRPC? gRPC is the European data privacy law that pretty much the whole world has to stick with at this point, because if somebody from Europe browses to your website, then you have to either lock him out or you have to conform with the European privacy law. So that's what gRPC is. And Microsoft can help you with that, but you also need to make sure you do that yourself, because it has to do with things like how do you retain data, how do you have people opt into things, do you allow people to be forgotten, the right to be forgotten, and things of that nature. Another question is, the GUI is very nice. What approaches are available for automation? Everything that I've just done here, you can totally script through a command line interface. So there's a very, very large CLI type of environment. There is, that's on a slide somewhere. By the way, you guys will all get the slides after this. There is an article we published in Code Magazine an issue or two ago that talks about the command line interface for all this. So anyway, this is now deployed, and I didn't really do any specific style sheets or anything here, but this is now our website that got deployed. If you now go to state.net.azurewebsites.net, you will see this website. I took out a lot of the styles yesterday because then it would take even longer to deploy. Oh, I'm sorry. Yes, somebody online said GDPR. I was explaining GDPR. The question was about gRPC. gRPC is a remote procedure call on that is replacing or supplementing REST remote procedure calls. So it's a more optimized version to do a remote call over HTTP that is gaining more and more popularity. I'm getting my acronyms confused here. So gRPC is rapidly becoming more and more popular, and it is supported well in .NET Core 3.x. So that is something you can now do out of the box as well, and we have an article on that as well. So that's, I guess the question really is actually the difference between gRPC and GDPR. So those are the two things. gRPC, remote procedure call, a technical thing. GDPR, a legal thing. So sorry about the confusion there. So that's the quick version of an app service. So you can do this today. You can spin up a free version of this, and you can run production websites for free. But then once you get into higher workloads, you can scale this up. You can add more memory. You can run multiple instances, and all of this just very easily done through the portal. So very simple, very straightforward. Now, as we continue our journey through the different interesting things, here's one. I'm not going to set up a SQL database right now, But this is certainly something that is very, very commonly done on the Azure cloud. You run some SQL workload in Azure. You can do this in a variety of ways. We just recently moved all of our own SQL workloads into Azure. Now we did this because, and I'll tell you about this later, we had a cyber attack that we suffered and it took down some of our servers, and at that point we decided let's move it all into Azure. And so we just essentially pushed our SQL Server up into Azure as is. That I would refer to as running SQL Server on Azure. And it's essentially a virtual machine on which a SQL Server is installed. Once you have that, you just manage it on your own, just like you would do any other SQL Server. You make sure you install the databases, you set up the users, all that type of stuff. You back it up. That is SQL on Azure. And that's a very, very easy way of moving your SQL Server stuff into Azure with essentially unchanged setup. And you then just connect to that and you can configure the security so only certain things can connect to it, and it works really, really well. That was our first step, but then we actually moved to something that's called SQL Azure, and there's some confusion around that. Do you run SQL Server on Azure, an essentially virtual machine, or do you run SQL Azure? And SQL Azure is a more purpose-built version of SQL Server. It's very, very similar to your own SQL Server, but it's built with Azure in mind. And when you do that, you don't worry so much anymore about how many machines do I have, do I install this or that version, do I update it? It's all managed for you. It's just SQL Server running in the cloud, and you just sign up for it, just like I just did for the app service. You can create a SQL database like that. You create the database, you create the tables, just like you always would in SQL Server. You can connect to it either through the portal and do some quick querying, but more likely you would connect to it through SQL Management Studio, or however you program SQL, maybe Entity Framework or something like that. And it just works. It's always patched, it's backed up, it has specific features like roll forward, roll back, the way it's maintained for you. So the only reason you would ever back up this type of SQL Azure database is because you could still mess up your own data if you accidentally delete a lot of records that you don't want to delete. It's not bulletproof in that sense. You could still logically do bad things. But other than that, for failure and so on, it's always backed up for you. You can replicate it very easily. You can scale it very easily because you don't have to worry about the infrastructure that's behind it. And so that's what we moved to ultimately. Why didn't we move to that right away? Well, there were some minor changes. For instance, Microsoft recommends you don't use text fields, you use varchar max. We still had some text fields in our old database. We had to move that over to varchar max. So I had to do some minor tweaking like that before we could actually move it into true SQL Azure, which is just kind of a bit of a more modern version of SQL. But so that was really, really cool and a great way to run our database workloads. Somebody's asking online, if you move a site to Azure, then how do you handle when your site loads data from a web service that requires an on-premise authentication inside a trusted network? Well, you could always do something like a VPN to that. Or there's a few similar connector technologies that Microsoft offers. So it is this hybrid scenario, like I said, is actually something that is definitely a strength of Microsoft. So definitely doable, probably a little bit beyond the scope of the talk here today, but follow up with us afterwards. Like I said, I'd be happy to get you some more pointers around that as well. Number 3, Azure Storage. Azure Storage, if you want to think of it, is like a big hard drive in the cloud. You can store what they call blobs, in other words, binary files in Azure Storage. You can also store files with structure to a certain extent. You can even make simple tables that have rows and columns, so almost like a simple SQL Server table, but it's not SQL Server. It's not as powerful as that, but you can do it for simple things. You can do queues. You can even do it as a true file map. You could actually map files into Azure Storage and just use it as an enormous hard drive if you want. What we use this for mostly is blob storage. At Code Magazine, we often deal with large files. So for instance, when we have a magazine that goes to print, that print-ready file is a very large high-res PDF file with hundreds and of gigs in size. We used to stick that into SQL Server, and that worked, but it wasn't great. Backing up SQL Server got to be a pain, and creating staging databases got to be a pain. Nowadays, we just stick it into blob storage, and there's a simple API to this. You can use it over REST, but if you're using .NET, there's a dedicated .NET API. It's very simple. You just say, I want to connect to the storage. And then there's helper methods to do things like upload a file, access a file, retrieve a file, add additional properties and information, metadata to a file. And then it just goes into this blob storage. It's a cheap place to store. It can be very large. It's essentially limitless in size. You can do geo-replication if you want those same files to be more accessible, geographically localized. And so it's a great file system. You can store things in what's called cold storage. So for instance, when you go and you download your latest Code Magazine issue, if you want in MobiPocket or PDF format, that is actually served up directly from Azure Blob Storage in a secure way, and it's very performant and easy for us to offer that to tens of thousands of subscribers that all download this on the same day. And that is called hot storage. It's very fast, reliable access. Now, things like the print-ready files, we need that once. It goes to the print shop, a physical magazine gets printed and sent out. Now, once we've done that, we're not accessing that file very much. We don't want to throw it away because we want it in case we ever need to go back to it, but it's not something we constantly need access to. And if it was unavailable for 5 minutes one day, that's fine too. And so that is cold storage. You can say this is a file that can go into cold storage, which allows Microsoft to use all the less efficient hardware to store this on. And that's a lot cheaper again. So you have different ways to do cost-efficient storage. Okay, we have a few more questions. Does Azure SQL support joining tables from multiple databases? No, it does not. So that would be more of a full SQL type of thing. So these cross database joins, you'd have to do separate queries. So that's not as efficient then, of course. And question about blob storage. Can Azure Blob Storage be used commonly with more complex .NET Core projects for assets? Yes, that's exactly what we're doing. So we're using this, you can call it an asset store if you want. There's a question about Azure Synapse Analytics. Does that replace master data services in Azure environment? I'm not an expert for master data services, so that's I believe that Azure Synapse Analytics is supposed to run in parallel with a lot of that, but I'm not an expert in this. But if you follow up with us after this presentation, I can get you those answers certainly. So that's Azure Storage, and storage is also important to know because Azure Storage is often used for other services as well. So for instance, if you want to do logging, the log may go into an Azure Storage location, and it's important to understand storage. But it's a very, very simple service to set up. There's no rocket science behind this. Now here's something that's cool. Azure Functions. Azure Functions are what's generally referred to as serverless computing, which most certainly does not mean no servers are involved. It's the most horrible name ever conceived. But what it means is you can run stuff on Azure and you do not need to worry about whether they are servers or not. You just say, I want to run this, and Microsoft takes care of all the server infrastructure that you need. So what could this be? This could be your API. We started out with app services, and we said, here is how you do an ASP.NET app. And of course, that ASP.NET app could be a REST-based API or gRPC for that matter. And that would be one way to go. But another way to go would be this: I don't even want to worry about the fact that I commissioned this server that this runs on, and then I have to scale this out and specify the CPU and so on, the memory. I just want I want to make these things that you can call, and I want them to run, and I want them to scale automatically and replicate, and I don't even care that there's servers involved. And that's exactly what Azure Functions are. So Azure Functions, you just go into the same portal. In the follow-up materials you'll get, I'll even include a sample of that. but it's very, very simple and straightforward. I'm gonna start creating one of these here. We're not gonna go into a lot of detail. We just don't have enough time here today, but just so we can return to this function in a moment. And so it's one of the popular ones, so here it is. And again, we'll pick one of our resource groups. We call this data.net function. And we can pick a runtime stack again and see that these functions can be made in a number of different things. If you're in this presentation, .NET Core is probably interesting for you. But why not do an Azure Stack one? Excuse me, a Node.js one, a Node Stack one. And we'll do the South Central US again. Oops. And while we're doing this, there's a few more questions. One question is, could functions be used to run scripts that do build infrastructure on demand? Yes, you could absolutely do that. You probably have better, higher level services in Azure DevOps and Git and many others. But yeah, you could absolutely use a function to do exactly that. App Insights, we don't really need. And so we'll let it create this function. So when you create a function like that, and this is available on different clouds, on AWS, this is called Lambdas. But when you create something like that, you create a function that is callable in a certain way or react to something. And one simple way of thinking at this is just like any old web service, a REST service that I can call when an HTTP request comes in. That would be one way to go. But a function can also do many other things. It can react to an incoming email. It can react to something that's stuffed into a queue. It can run on a schedule. So you can say, I want to run this every 5 minutes, for instance. And so it's essentially an event-driven environment. An event could be as simple as a web request, but an event could also be a number of other things that could happen in the environment. And so it's very, very flexible in that sense. And anyone who's ever created a REST service that they then wanted to run once an hour, know that it's actually not that simple to respond to other events, right? Like, let's say you want to respond to an inbound text message, be difficult to do with just a web app, but it's relatively easy to do with the function app. So here's the function app that got created. We'll let it load the details here, and then we'll drill right into the functions. One way of creating functions within this app is to do it right here through the portal. Now, most of the time, you wouldn't develop a large system like that. You would use your local development environment and then deploy to it, which is certainly also possible. But in our case here, for a simple example, we'll just click the Add button. We'll add a new function that's outside callable here. In this case, we'll call it Hello World. Hello World is actually a kind of a funny example in the Node.js one, because the default template it creates is one for a Hello World. So we'll just use that. We can do authorization. We won't worry about that for now, but you can secure this whole thing, of course. And here is our first function. And again, it'll load all the details for this. And you can go right into code and test here. And in this case, we'll see the node.js setup that is used to run, in this case, this hello world function. Now, we could even start online here and then take it offline and start developing more locally. But here you'll see we have a very simple hello world function. And basically what it does is it creates this JavaScript-based function that runs async, does a little bit of logging. It looks at the request that comes in, looks at the query parameters or posted parameters, and then sets a return value in the body here. And if it doesn't find any parameters, it returns an error. And we could simply go ahead now and we could test this. And we could say we want to call this method as a post, or we could call this as a get. Then we could add a query parameter if we wanted, called name. We make this Markus, and we now go ahead and run this. And this is now a live function. You could do this. If I give you the URL for this, which I could get by clicking this button here, you could now run this application, and you see here is the response that we got back from it. And in fact, we could just grab this URL, copy it, open a new browser window, and if you read this URL and you put it in, and we'll add another parameter here, we could now run this through our website, and as you see here is the response that this particular function returned back. Now typically that would be a JSON response, or it could be HTML even if you wanted it to be. And boom, now we have this running Azure function. Now again, I did this in Node.js because I wanted to show you something a little bit different, but of course you could have done this in PHP, you could have done this in C#, and in C# you would have typically just downloaded it, did a local development, it just becomes C# development there then at that point. Now let's go back into the add function interface here one more time real quick. And I just wanted to show you some of those other triggers you have. I use the HTTP trigger as the event that caused the function, so we could use it in the browser. But you could do it, like I said, on a timer. You could do it based on queue things that come in. You could put it based on blobs that get stuffed into blob storage, and so on and so on. So you see there's many different ways to trigger some of this. So that's Azure Functions for you, and you can use this. You could do your entire API-based backend using Azure Functions, and in fact, this is done very often, right? You could build up your, say, Angular or Vue web application with an Azure function-based backend. The one downside is Azure Functions tend to have a cold start penalty. In other words, if it's not busy, it takes a moment to start up on the first hit, and then it's very fast. To get around that cold start penalty, you can pay for a higher tier, but at that point, it's not as cost efficient anymore. And I saw there was a question about cost efficiency. How cost efficient is Azure? Well, that's hard to answer on a general level because it depends totally on what you do. Azure Functions, very cost efficient. Blob storage, super cost efficient. Running web apps may be free, but if you're building up a very large environment, it can go and become expensive. And you can, of course, use certain services that may be higher cost than others. So you can't answer it across the board, but yes, the whole appeal of Azure, of course, is that ultimately it is more cost efficient than running enterprise infrastructure. But if you're just running a small website and you start scaling that up and it's your personal website, it may have been easier to run that with some simple hosting company or something like that. Can you publish a function from VS just like the app service? Absolutely, it's almost the same experience. What sort of version control is there available for Azure Functions? The way we do it is it usually becomes standard Visual Studio development. So we do a lot of our Azure Functions in .NET Core. We're using C#, and then it's just a C# project that gets into something like GitHub or Git or Azure DevOps or something like that. I believe there even is some other versioning built in if you just went through the portal, but I'd have to get you the answer to that. But the more professional way, I think, is to use some standard version control asset management system. Okay, I'm already a little over time, but I'm still going to go through a lot of those. Azure Kubernetes service, very, very interesting. Containerization for larger systems is super important today, using things like Docker containers, which is essentially taking an app and putting it into a small virtualized box that this app runs in with everything it needs, and you then just deploy these containers to servers, and they just run side by side. They don't impact each other. If you need more, you can just scale that up. Now, if you do that scaling, then you need a larger setup that allows you to orchestrate how that scales up, how it gets replicated around the world. And that in a nutshell is Azure Kubernetes service. So that's made especially for that. As of this last week's build, it now supports Windows containers. It now supports spanning multiple data centers. It now supports even multiple clouds. So if part of your containerization involves both Azure and AWS, you can use that. It can include Azure Stack. So very, very interesting. Probably the topic of a future State.net, just what is Kubernetes and how can you use it, because it's very, very interesting. But so you should be aware that exists. Another thing that you should be aware that exists is Cosmos DB. Cosmos DB in a way is an alternative to a SQL Server database. Okay, so what this is it's a NoSQL database similar to MongoDB, Cassandra, Couchbase, and many of those. But it's the first one that has been truly built for the cloud. There's no concept of servers. You just create a Cosmos DB database. You specify where you want it to be available in the world. It is fully managed for you. You never worry about servers or patching, or it's just this limitless thing that you can put data into. And you don't have to back it up or anything like that. And the cool thing about it is it has many different ways of getting to it. So you can almost pretend it's a MongoDB database or Cassandra or more like a SQL database and access it using those infrastructures or those APIs. So again, probably the topic of a future State.net talk all on its own, but you should be aware that it exists. It's a very interesting offering. For my penultimate trick, I want to point out to you this new concept of static web apps. This has just been announced at Build last week. It is now in preview. And what static web apps is, it's almost like the app service that we looked at, except it's highly optimized and streamlined for applications that do not need to do server-side processing. So if you build, let's say, an Angular app or a Blazor app, another topic we'll talk about in next month's State.net actually, or if you have a Vue app that is really just HTML that gets loaded on the client and then executes entirely on the client. If you have that kind of an application, you really don't need to spin up a powerful back-end processing .NET Core type of environment that has so much RAM and so much processing power. All you need is a place where this stuff is stored and gets served up like a website to the client that is pinging it. And that is essentially what static web apps are. It's highly efficient and optimized for that. And interestingly enough, it has very tight integration with GitHub. So you can just push into GitHub, make a trigger or make a certain branch that you want to use for your live deployment, and the static web app feature then picks that up and it just deploys for production or staging or whatever you want. So a workflow, DevOps style workflow built in there right away. I believe in the future you'll also be able to use it with things other than GitHub, but that's what it does right now. And it's an example of how Microsoft is starting to integrate GitHub, which they now own, more tightly into their system. So very, very interesting, a very cost-efficient way to run those types of apps. And then, of course, if you have that type of application that entirely runs on the client, but probably needs to access data and services, now a function app can serve as the services very well. And finally, for my last thing that I want to show you, super cool topic, Microsoft Cognitive Services. Now, Microsoft Cognitive Services is a huge topic that each sub area of it would probably warrant the whole State.net, and we'll probably do that in the future. So Cognitive Services is all about AI and machine learning. It's an umbrella term for different services. So the things in there like vision, there are things in there like speech, language recognition. Azure Search is super interesting. And just to give you a quick example of what you can do with some of those subsystems, I want to show you a website that we've created here as a community effort as part of the response to our COVID-19 problem. And that is what we call our Buy Pono effort. Pono is a Hawaiian word that means essentially doing the right thing. And Buy Pono allows people to find local vendors. It's, if you will, a global platform to shop and consume locally. And so what we have here, for instance, is a map of Maui. and it shows different services that exist in Maui. And I could now go in here and I could start searching for this, and I could say, I want some tacos. How can I get some local tacos here that are locally sourced and locally produced from a local vendor? And so when I do this, I need advanced search. I don't just want to do a full text search, but I want some search that understands what does the word taco mean? I'm probably looking for Mexican restaurants. What if I misspell the word taco? And then once it understands that you're looking for that, what is the most likely taco place that you want to find? And so doing that kind of a search, that a Google style search essentially over your own data, is a difficult thing to do. It's something that everyone needs, but it's very difficult doing a ranked search, an AI-based, an artificial intelligence-based search that serves me up some things that are really interesting. And that's what Azure Search does. So this website has a SQL Azure database behind it, but we then also take some of the data out of SQL Azure and we stick it into this Azure Search as essentially a JSON document. It's called an index, but when Azure Search talks about indexes, it's really a table. And you can then search in that index. You can say, this field is more important than that. And this field, analyze it as English language so you understand that a misspelled taco is still a taco. Or that a Mexican restaurant is related to tacos and stuff like that. So it does a very natural search and you can fine tune it. You can then combine it, like in this case, with geographical search. And therefore, with all this functionality, we were able in almost no time to create a very, very powerful version of the service that we wanted to provide for the community, so they can find what's still open and where can I get things. I would like to buy more local now. Where can I find fresh produce, for instance, and who can provide that? And so Azure Search was a cool thing to do that and do it quickly. And that is just one example out of I don't know how many different sub things that are in cognitive services. Vision is super interesting, analyzing images, finding faces and identifying them. Speech recognition, language output, artificial language generation, knowledge-based search. The list goes on and on. Machine translations, all of those types of things fall under Azure Cognitive Services. And you have some links here that give you some information about articles we posted. And again, you're gonna get the slide deck. So that in itself, super interesting topic that will keep us busy for several different Stata.nets in future installments. And these days, there's almost no application that I find where I couldn't think of a way of how any of these cognitive services could apply. Like for instance, we did an application for a company that did perishable goods like salads and fruits and stuff like that. And they created a product database, and we used some of the image search features to make sure that the images that were posted looked like they were fresh, and we didn't have a disgruntled employee who posted something we didn't want and stuff like that. And you can analyze that. So that's my 8 services that I wanted to highlight. Quick word about security, by the way. A lot of people always ask me about security. Do you really trust the cloud? What do you do if somebody attacks that? I don't have control over it myself. And the reality is, the cloud is much more secure than anything you can do yourself. First of all, Microsoft is a security expert. But then I also want to give you a very specific example. Code Magazine, or Code as a whole, my company, became the target of a major cyber attack. It was a ransomware attack, so no data was stolen or anything, but they tried to take all our infrastructure hostage and extract some money from us and a lot of money to decrypt all our information. And those are attacks that are becoming very, very prolific in recent times. So this is a real problem now, is these ransomware attacks. And what happened to us is we luckily had a really good backup infrastructure. We had 15-minute backups and so on, so we could actually rebuild our infrastructure. But it was interesting that everything that was in our local data centers and offices was affected by this attack, while the cloud was not. Everything we had in the cloud it was completely safe. And the stuff that wasn't safe, even things like Dropbox and OneDrive, it was affected and it spread the attack very efficiently, but at the same time, we could just roll back a day and everything was forgotten. So a very interesting lesson to be learned. We'll be publishing some articles about the anatomy of that attack and how we recovered from it, because I think we did very well. And I think it's interesting for a lot of people. But a key takeaway there is about half of our infrastructure was on Azure at that point and other clouds. And that was entirely secure. Nothing bad happened to it. And now we moved everything to the cloud and haven't had a problem since, knock on wood. It's not out of the question, but it's certainly more secure than the things that we as a small company can spin up. Online question. It's back to the Azure Search. Is that kind of like Elasticsearch? It's exactly the equivalent of Elasticsearch that Amazon provides. So very often cloud providers will provide similar services, and Elasticsearch would be the other alternative. All right, and that brings us to the end of the presentation. I'm already way over time, but hopefully this was interesting. Like I said, we'll go into a lot more detail in future events. Few other announcements that I have. Like I said at the beginning, if you sit there and say, I wonder how that applies to me. Could I use any of that Azure Storage, that Azure Cognitive Services, whatever, or something that I didn't talk about here today? How would that apply to me? Feel free to give us a call. Feel free to send us an email at info@codemac.com. We are happy to set up a free consulting session with you. We call it an hour of consulting. It takes an hour and a half. You're still not going to charge you for it. This is just a free offer that we provide to the community to address a very typical style of question that usually comes up. Another thing, if you haven't seen this yet, I didn't talk much about Code Magazine today, but of course Code Magazine is an important business of ours and has been growing like crazy lately. If you are what's now called a VSS subscriber or a Dev Essential subscriber, essentially MSDN subscriber as we used to call it, you can now get a free copy of Code Magazine. Feel free to pass this on to your friends. You go into your Microsoft portal, you click on this Code Magazine link right here, and you can then get a completely free Code Magazine, even print edition or digital edition, whatever you would like. Also, if you came to this event, we'll extend a free offer as well. We also, especially because of this coronavirus crisis, pushed out very quickly new mobile apps for iOS and Android. So you can now read Code Magazine on iOS and Android. And while this corona crisis is going on, we made all content we own, every issue of Code Magazine ever published, we've made free on these mobile apps. So all you need is a subscription of any kind. Now you may say, well, I don't have a subscription. Go to this link at the bottom there, codemac.com/subscribe/corona will give you a free subscription. We just need, for technical reasons, a subscription to tie it to. But that's a free digital subscription, and you will then get access while the crisis lasts to all the content. And then after the crisis, we'll probably scale it back again to just the issues that fall into your subscription, but that will always be there. And feel free to spread that, share it with your friends and colleagues. It's just something we're trying to do during this crisis while people are stuck at home. Now the next event, next Data.net event like this will be June 24th. We'll focus on Blazor web development. So the new Blazor framework that Microsoft has running native .NET code in the browser, in any browser. It's an open standard called WebAssembly that this stuff runs on. That is what we'll focus on entirely on the next application. Next event. Question online, did we produce the iOS and Android apps in Xamarin? We did not. In hindsight, we probably should have. So we actually created Swift and Java apps to take advantage of the unique features. In hindsight, it probably turned out that we could have used Xamarin as well. Our original thinking was we want to make very, very handcrafted experiences for each environment. But I think in hindsight, everything we did could have actually been done in Xamarin as well. And these apps were pushed out somewhat rapidly to support the digital offerings we wanted to push out for the coronavirus crisis. And these apps are still going to grow, so there'll be lots of other features in them, and we'll see if Xamarin would still be able to do that, but I do think so. And Xamarin, by the way, very interesting, probably another topic for a future State.NET. Microsoft just announced an initiative called MAUI, which stands for Microsoft Application UI. And that is essentially Xamarin growing into all kinds of desktop development, unified desktop development in the future. So very, very interesting developments there as well. And with that, I want to end the presentation here today. I'm already over time, but I hope you found this useful. And if you have any questions, feel free to contact us. Again, consider us a resource. We're not the kind of company that will send you an invoice for answering a quick question. So thank you very much. Send us suggestions for future State.NET events. Hopefully the next ones, we won't be in lockdown anymore, have a little bit more of a regular setup rather than doing this from home. But I think it worked hopefully pretty good. So thank you very much. If you have any questions, I'll stick around for a little bit longer. And other than that, we'll end the presentation here. Thank you.